Hi friends, welcome back. Today we are going to solve LeetCode problem 1557, minimum number of vertices to reach all nodes. Before we go through the description and the examples, I want to mention that my channel focuses on helping people who are preparing for coding interviews and Java interviews. My channel has a lot of solved problems asked by many big tech companies like Amazon, Apple, Microsoft, Google, Facebook, etc. And those problems are handpicked, provided like different kind of varieties of problems that includes dynamic programming, linked list related problems, string related interview problems, graph related problems, binary search tree related problems, and logic based problems that were previously asked in the coding interviews. If you are preparing for coding interviews or just simply learning Java, please subscribe to the channel now. So let's look into the description of this problem. Given a directed acyclic graph with n vertices numbered from 0 to n minus 1 and array edges where edges of I is from I to 2i represents a directed edge from node from I to 2i. Find smallest set of vertices from which all nodes in the graph are reachable. It's guaranteed that a unique solution exists. Notice that you can return the vertices in any order. So they have given us two examples, and this is a directed graph, right? So there is a direction for the edge, right? So let's take these examples over here and we will discuss examples and propose our solution, and then we will discuss the implementation. So this is the first example. So so as you can see, if we want to visit all the nodes in this graph, then for example, if we choose 0, then we can visit 1 and 2 from 0, right? And if we choose 3 here, then we can visit 4 from 3. From 4 we can visit 2 again, and from 2 we can visit 3, right? So 3 also is visitable from 0 also, right? So from 2 to 5 we can visit from 0 also. So it means that we can visit this whole graph. So for that we have to include 0 and 3 into our set, right? So this is the smallest set we can use to visit the complete graph basically, right? And this is a directed acyclic graph, so DAG, which is the edges are directed, right? So in the second example, if we choose 0, then we can visit 1, right? And from 1 we can visit 4 here. From if we choose 3, we can visit 1 from 3, right? So 3, anyway, if we choose 3, it means that we can visit 3, right? And if we visit 2, then from 2 we can again visit 4 and visit 1 also, right? So it means that to visit all the graph nodes, we have to choose set such as 0, 2, 3, right? Then only we can visit all the nodes into the graph, right? So this is what we have to output basically. So this is the problem that we have to select minimum number of vertices that can cover all the that can be able to visit all the nodes in the graph basically, right? That is the problem. So let me just revert back the coloring so I can reuse this whiteboard again. So how we are going to solve this problem is we will take every node and we will calculate the in degree of that node, right? In degree means that how many edges are coming towards that node, right? So for 0, let's say for 0, the in degree of 0 is 0, right? Because there is no edge which is coming towards 0. So in degree of 1 is there is one edge which is coming towards 1, right? This one. So we have to put 1 as in degree. For 2, the in degree is 1, 2, right? Because two edges are coming towards node 2. So in degree is 2. For node 3, in degree is 0, right? Because there is no edge which is coming towards node 3. And for 4, there is one edge which is coming towards 4. And for 5, there is one edge which is coming towards 5, right? So we will prepare this in degree mapping, so we will know that how many edges are coming towards that node, and we will go through these in degrees and we will find out all the in degrees that are 0, right? So we will choose this one and this one, basically, right? And we will just output them as a set, right? So 0 and 3 is the minimum set basically that can cover the vertices, and you can reach all the nodes basically into the graph by selecting those uh, two nodes, right? 0 and 3, as you can see here, 0 and 3. We can, if we select that, we can reach all the nodes, like from 0 we can go to 1, from 0 we can go to 2, then 5, and from 3 we can go to 4, right? So all the nodes will be covered, because and start we are starting from 0 means 0 is already covered, we are starting from 3 means 3 is already covered, right? So that is the approach we are going to take to solve the problem of finding minimum number of vertices. So as you can see, it's logically makes sense, right? That whenever there is no in degree, right, then we will choose that node, so that we will have out degrees basically, right, that we can go and visit. And we will choose all the nodes that has in degree 0. So similarly, if we see this graph, right, so in degree for 0 is 0, 3 is 0, and 2 is also 0, right? And then we can go from 0 to 1 and from 2 to 4, like this basically, right? So all these nodes will be covered if we select 0, 3 and 2 basically, right? Because in degree for those nodes are 0. In degree for node 1 is 1, 2, 3, right? And in degree for 4 is 1 and 2, right, basically. So this is the logic. So let's look into the implementation quickly, and then we will go through the unit test cases. So I just first created a answer list of integers that we are going to return at the end, right? Then here we are going to like I created an in degree array with the same size and number of nodes, right, n. And then we are going through the edges, we are getting the source and destination from the edge, and we have to put like in degree of destination plus plus, right? Because destination, as you can see, 0 is source, 1 is destination, right? When you go like this, then we have to increment in degree of the destination node, right? So that's what we are doing here. And after that is done, we will go through all the in degrees and we will check if there is any in degree which is 0, then we will just add that in degree into our answer list, right? And then at the end we are going to return the list. So that is the approach that we are taking. So let us first use the examples that we have here, right? So let's just quickly run these unit tests. So for first we should get 0 comma 3, so we are getting 0 comma 3 for first, and for second we should get 0 to 3 and 0 to 3 we are getting, so both have passing. Then let's just modify this first example. So instead of, let's say, instead of um, so we can take, we can actually, we will just take the another example, this example, and we will just modify this example so that instead of 1 2 we are just going to make this as a 2 1, right? 2 1 instead of 2 1 we are making it 1 2, right, from for here. So in this case, let's just run this quickly. So what we have done is we are now doing 1 to 2 basically, right? That's what we are doing. So now 0 to 3 we should be able to go everywhere, right? 0 to 3, right? 0 and 3 we can reach all the other nodes basically, as you can see. So this is also passing, so let's just submit our solution. So our solution got accepted with 73% better than other codes and 72% better in memory. So this is the way you can solve minimum number of vertices to reach all nodes. Lead code problem is of medium complexity. So you can use the logic of in degree, right? We will just choose the in degrees which has nodes with in degree 0, and then we will form the set of minimum number of vertices. If you haven't already gone through my playlist of LeetCode and LeanCode solutions, please go through it. It has over 150 solved examples explained explained with Java code, and those problems were taken from previous interviews asked by big tech companies like Microsoft, Amazon, Apple, Google, Facebook, etc. The problems has variety of playlists, variety of videos such as dynamic programming related questions, questions related to linked list strings, as well as graph questions, binary tree questions, binary search tree, binary search related questions, and logic based questions. So please go through it. It will help you in preparing for your coding interview exams. As well as if you are preparing for telephonic Java interviews, there is a playlist called as Java interviews. Go through it. It has a lot of telephonic questions asked, like discussed, and how to answer them is also discussed. If you like this video, please hit subscribe and like it. Your subscription is really important to us, because that is the way the video can reach to more people. They can also watch these videos while they are preparing for their coding interviews and Java interviews, and they can get help by watching these videos. So please subscribe to the channel, and thanks for watching the video.